course content is listed here. There will be chapters related to the fundamentals and principles of reinforced concrete structure, and there will be chapters about the design of reinforced concrete members. When it comes to the design of the reinforced concrete members, all the basic principles shall be adopted. Because of this, we will need to make sure all the essential topics are being covered. Let's say now, by looking at the course content, a few essential things has been identified. The student should have the ability to analyze the structure, determine the moment and shear acting onto the members, and the student should have the ability to design different types of structures. For each type of the structures, there shall be service and durability requirement. The design of the structures shall be based on limit state design, and the value used in the design shall be on the basis of the properties of the material used. With that, we are able to cover all the topics in 4 questions. The first question, it will be about the analysis. Second questions, the design of beam. Third questions, design of the slab. And the fourth questions, the design of the stairs. You can actually streamline the exam questions so that all 4 questions are interrelated. The value as acquired from the analysis of the structure shall be used to design the following sections. This is one of the ways having the final exam interrelated. As is when the students go through the final exam paper, the students have completed a small scale structure, and this is allowing us to have a thorough assessment in terms of the level of understandings of the students. On this basis, let us see this example. These papers have 4 questions. First question is about the analysis. The second question is about the design of the beams, moment and shear, and also serviceability requirements. And then you may proceed with the design of the slabs. Design for moment, shear, consider the serviceability, and probably some detailings of the structure. And then next, you may proceed with the analysis and design of the staircase. When you have all this connected together, now the final exam serves as an exclusive summary to the students, going through the entire course within the stipulated durations of 3 hours final exam paper. However, there are disadvantages for you to set the final exam questions in this mode. Let's say now students cannot answer question 1. The error shall be unintentionally brought forward to the next questions. Whichever mistake done at the early part of the calculations shall influence the following parts. With that, when you assign the marks being allocated to the paper, don't just allocate marks on the correct answers. Normally, we will allocate marks for the steps, because we would like to know whether they fully understand the concepts. Another way to overcome this problem, you may break down the informations into several questions. You only disclose what is necessary in the question 1 when you want the student to solve the question 1. This will reduce the amount of unnecessary information to the students when they are answering the question 1. Now, when the students move to the questions 2, whatever information which has already been specified in the question 1, you don't have to specify it anymore. This is to prevent the redundancy. Based on my personal practice, Normally, I will not create a totally new questions for the second question. This is in order to reduce the time of the students to understand another structure. The intention here is to save the times for the students, focusing on one type of structure based on one consistent set of specifications. This still haven't solved the problem. If the students have some errors in their previous questions, the error will be brought forward to the next question, which is unfair to the students. Normally, based on what has been analyzed in the previous question, I will have the respective value redefined. Sometimes I define the same value as per what has been analyzed. By the time they enter the questions 2, they will more or less know that whether they have done question 1 correctly or not. Or if you want to prevent the students acquiring the hint from your question 2, you can redefine the loops without significant changes in terms of the specifications given. There should be additional informations being added on top of the question 1, especially when you need those details in solving the question 2. In that case, make sure you provide the relevant details. Same principles apply to the following questions. We still haven't entered how we deal with the calculations questions. As a sharing to you, this is one of the ways that you streamline everything in the final exam paper. The principle is, you need to know the purpose of you doing this. You should also aware of the limitations of this approach. You have to find some way to minimize any possibility that can affect the accuracy of your assessment. Your ultimate goal here is not to make the exam paper to be extra hard so that the students can fail the paper. Your goal is to assess the level of understandings of the students. In fact, when you streamline everything together in one exam paper, there are dependency of the details and specifications given. This has already made the exam paper to be quite difficult to score. Now when come to the assessment, it is nearly impossible for you to cover all the small topics in each chapter. You will have to choose those which you feel is essentials and critical. Your final exam paper will serve as an synopsis to your course. Going through it is like students going through a synopsis of your course. This is one of the ways to do it. If you have some other ways to do the paper, feel free to share. Probably we can learn from each other. Now coming to the marking schemes. You can have sub-questions guiding the students through the solutions from your question 1 to your question 4. Clearly define the marks allocations, and in your marking scheme, you should make known to the moderator about the specifications of the questions. CO2 means that this sub-questions is meant to attend to the course outcome 2, and the topic is chapter 2. C4 is the cognitive level 4, which is about the analysis. Then the instructions of the question will have to reflect the levels of cognitive level. If you are dealing with C4, that means you're looking into the component of analysis. Then you will have to make sure the questions has analysis. In this case, you provide a structural key plan here. Provide the details and the specifications of the structures, asking the students to analyze the actions acting onto the member. This is analysis. Next, you ask the students to determine the moment and share by using the moment distribution method. This is structural analysis, which is also analysis. Based on the result as acquired from the moment distribution method, you ask the students to construct the shear force and bending moment diagram. You know that when you deal with the moment distribution method, there should be a lot of load combinations. Maximum all, max min max, min max min, and so on and so forth. This will have to go back to the fundamentals of doing assessment for final exam. Your intention is to know whether the students can have the relevant knowledge to answer the exam questions. If the students can do the moment distribution method, you don't have to ask the students to do it for different load combinations, as the relevant step will be repetitive. You will have to minimize the redundancy in setting the questions. My personal practice is, I will make sure that one type of principles, theories, or steps will only be assessed once in the final exam paper. Unless it is really necessary, then there could be minor repetitions. Otherwise, I will try to minimize the redundancy. And then, based on the shear force and bending moment diagram acquired, enters the following questions. Normally, I do not mind to provide the answers for the question 1. In question 2, this will reduce the psychological pressures by the students if they are not confident with the question 1. Sometimes I just simply put other values. It doesn't really matter, but the relevant key planes, dimensions of the beam shall be made standardized based on the question 1. The same principles apply for the other questions. Now let us look at the marking schemes. There are few ways for you to identify the marks allocations. You can allocate marks by half a mark, one by one. You may also allocate the marks by 1 marks minimum. It depends on your preference. I see some lecturer prefers to have half a mark as the smallest interval. Initially, I used that also. Then the allocations of the mark, it will be more precise. This is okay when you have a small group of students for your course. Let's say now you have a big class. After the final exam papers being conducted, university give you an SOP of 7 days marking. If you have a large group of students, you'll be rushing for the results. The more refined you allocate the marks, you will spend more time on one paper being marked. The advantage is that the marks given will be more precise. The disadvantage, it takes longer time for you to calculate the marks for each student. You may consider this while designing for your marking schemes. Strike a balance between the accuracy and also the practicalities. Let's say now you have decided the smallest interval to be 1 marks allocations. That means the allocations of the marks, it will be less precise. There could be some calculation steps without any marks, such as in these areas. Then you will have to strategize where you're going to allocate the marks. The marks should be allocated for the significant calculation steps and also the answers of the questions. If the students do not get the answer right, make sure there will be some marks for the calculations. You cannot penalize the students entirely when it comes to the calculations errors or some writings errors there. You may deduct the marks on the answer, but if their steps are correct, you should give them marks accordingly. Normally when I do the marking, let's say now 1 mark is assigned here. The students will have to get the entire statement here correct to be eligible for full 1 marks. If there are any mistakes somewhere in between, I will deduct the mark by half. Same goes to this. When I allocate 1 mark here, that means I'm looking at the steps here and also the answers here. If any of this having the wrong value, then half a mark shall be awarded. It will be either 0 mark, half a mark, and also 1 mark. This may be arguable. Different person may have different practices. To me, what is more important, it will be the consistency in awarding the marks. Why not 0.25 marks or 0.75 marks? This will be from the perspective of the practicalities. You can quantify the marks by ratio, but there are too much decisions that you need to make throughout marking a paper. This is going to influence the time that you have to deal with the students. So, based on my personal considerations, 0 marks will be given when the entire thing is wrong or the students have no solution for that particular part. 1 marks it will be when the students provide the full correct answers. There shouldn't be any mistakes or error. Whatever is in between, it will be considered partially correct. In that case, I will just allocate half of the marks given. This is to prevent the confusions. Now, when you allocate the marks, you have to clearly indicate where are the locations the marks shall be given. Make it clear to the markers. In some universities, 1 course is taught by several lecturers, but there will be only 1 set of exam paper. Whoever prepare the exam papers will have to make sure the marking scheme are clearly outlined, so that all the lecturers are marking on the basis of the same standards. In some university, the entire course is taught by 1 single lecturer. This shouldn't be a problem because the consistency is there. Now, another question about the calculations is that whether the equation shall be given marks. This may also be quite arguable. Some say that the equations are already given. Marks shall not be given to the equations. If we want to give marks for the calculation steps, marks shall be given when the students correctly substitute the equations. I feel this is quite justified. Normally, if you do this, your marking scheme will be less arguable. Sometimes you see lecturer also allocate marks for the equations. For example, as shown in the marking scheme here. This 1 mark is given for the equation here, another 1 mark given in the equation here. There shall be marks given to the answer and also marks given to the answers. Their considerations, it will be the equations has been considered as the calculation steps by the lecturers. There are limitations in terms of this approach. What if the students cannot give you the right calculation steps? Students do not know how to answer this question and just simply write down the equations so that you can award the students some marks for the questions. This will have to be depending on the professional judgment of the lecturer. We go back to the fundamentals of doing assessment for the final exam. You will have to look into the students' solutions and determine whether the students really know how to answer the questions. If the students do not know really how to answer the questions, simply write down the equations. Theoretically, marks shouldn't be awarded. It is also possible that students know how to answer the questions, just that the students do not have sufficient time to do all the substitutions. In this case, normally the students will arrange the equations in the proper sequence. Since they do not have sufficient time to do the substitutions, based on the sequence that they have arranged, you know that they actually know how to solve the question. Normally, if this happens, marks shall be allocated. The next question, it will be the amount of the marks given. If you want to minimize the level of argument in terms of the allocating the marks to the equations, trying to prevent the students who do not really know how to answer the question, copy the equations and seeking for the marks. You can actually reduce the amount of marks being allocated here. Instead of having full 1 marks here, you put 0.5 marks. As for another 0.5 marks, you make it as a part of the substitutions. In this case, students will need to write down the equations, do the substitutions, and then find the correct answers. It will be half a mark here, half a mark here, and another full marks here. And this will reduce the argument there. Whatever it is, you cannot deviate too much from the purpose of doing the assessment. How do you allocate marks here? To some extent will influence the scoring of the students for that particular paper. You can make it very strict that you do not allocate marks for the equation. You only give marks when students do the right substitutions. This will make the students harder to score. As copying the equations is normally easier, it will take time for the students to substitute every single component of the equations. Students will need to comprehend the unknowns there and substitute the right value. If you do the marking scheme in this manner, it will be more challenging for the students to score. Now, if you do not require the students to do the substitutions, as long as the students give you the equations, marks is given. Even though students do not go through any substitutions or calculations, simply put any value as the answer. Another half of the marks shall be given, and this is going to be lower the difficulties of the students to score in your paper. If you do this, you have to be slightly more careful if there are students playing around or cracking with your marking system. What if the students know how do you allocate the marks? Without going through the paper, simply copy the equations and give any value, seeking for some marks even without studying the course. In this case, probably you have to do some simulations. If the students do this, you make sure the students cannot pass the paper. Personally, I did some analysis. If the students use this way to crack the marking scheme, the most that the students can score without fully understand the paper, without knowing how to solve the questions, it will be somewhere 1/4 or 1/3 of the total marks of the paper. Students are still unable to pass the paper. At least you have to control at this level. You cannot allow the students to pass the paper without really knowing how to solve the questions. Now, coming back to the discussion just now, how strict would you like the marking scheme to be? You know that it's going to influence the score given to the students. To me, there is no standard answers how it should be. This is very much dependent on the experience and what the lecturer embraced. If you feel the equations is not qualified for full marks, you can reduce the mark. If you want to prevent the students scoring simply by writing down the equations, you can remove the marks allocated, but make sure you will have to have marks for the steps, which these substitutions of the value should be given marks. Another perspective that you can consider, you can look through your previous experiences. What are the overall score by your previous students? If the questions is being set really hard enough to the students, they find difficulty to score the paper. Even good students also barely pass the paper. Probably you can release a bit tension at the marking scheme here. Let's say now if you find your questions is relatively easy for the student to score, although it's already reaching toward the intended depth and specifications of the paper, many students can score very well, even those moderate students. Then probably you can stringent a bit in terms of your marking schemes. This will have to base on your experience and also professional judgment. I'm not saying that you can manipulate the assessment, as manipulating the assessment totally deviated from the purpose of the assessment. What I am saying that is, sometimes when we set the questions, it may not exactly to the intended levels of difficulty that we perceive it should be. You might need to also look into the overall performance of the students to verify what you intend the questions to be. In this case, based on the outcomes given by the students, then you use the marking scheme to slightly fine-tune it towards an appropriate levels of the difficulty in scoring for your paper. The ultimate goal here is still for you to improve your accuracy of the assessment. It is not to manipulate the result from the assessment.